4.2 factorials and permutations. So in many situations, we need to determine the number of different orders in which you can choose or place a set of items. Okay? So in this case, in this entire lesson, order actually matters. Okay, so it's not just a group or like a mixture of things, like the order or like the title on something matters. So I'm going to write title here. Okay, real life examples of this include the order of presentations in a classroom, electing a president, vice president, and secretary, for example, or the order in which the first 3 people complete a race. And obviously the order matters because you podium. Okay, so factorial. For any natural number n, so when we talk about the natural number system, this is the numbers that are positive integers. Okay, so 1, 2, 3, 4, all the way to infinity. It does not include 0 and it does not include negative. It starts at 1. Okay, when we see something with n exclamation mark, we call this n factorial. Okay, so the way we actually expand it for n factorial is we take n as it is and we multiply it by the next number down, multiplied by the next number down, multiplied by the next number down, and we keep doing that all the way to 3 times 2 times 1. Okay, so let's look at hands-on examples of this. So evaluate each factorial. So 2 factorial would expand to 2 times 1, which is just 2. 4 factorial would expand to 4 times 3 times 2 times 1. And if you were to actually put this into your calculator, you could do 4 times 3 times 2 times 1, which is 24. Or you can locate the factorial button on your calculator and put in 4 factorial and you'll still get 24. Okay, for 8 factorial, we're doing 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, I'm not putting this entire thing into my calculator. I'm going to put in 8 factorial and I'm going to use that exclamation mark and I get 40,320. Example 2, evaluating factorial expressions. So if we had something like 10 factorial over 5 factorial, we can do this one of 2 ways. So I'm going to do the completely expanded version. Okay, so if we did 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is super tedious, but you can do it this way. And then that's going to be over 5 factorial, which is 5 times 4 times 3 times 2 times 1. If we take a look, the 1's cancel out because 1 divided by 1 is 1, 2 divided by 2 is 1, 3 divided by 3 is 1, the 4's and the 5's cancel out. If we actually look at this section here and this section here, these are identical. So all of these cancel out and we're actually left with 10 times 9 times 8 times 7 times 6. So if you want to look at this as the expanded version, we can type this into our calculators. We get 30,240. Now, if you're comfortable with the factorial button in your calculator, you can put in 10 factorial divided by 5 factorial, and it's still going to give you 30,240. As soon as you get to numbers that are too big for your calculator, such as example B, the number will no longer populate on your calculator. It'll just say math error. And it doesn't mean math error that that number doesn't exist. It just means it's too big for your calculator to compute. So I'm going to show you the shortcut way of doing it now with B. And this is a much easier way of doing this. So 83 factorial. I'm going to expand 83 factorial until I get to 79 factorial. So if we wanted to expand 83 factorial, we'd get 83 times 82 times 81 times 80 times 79 factorial. So instead of taking these 79 numbers and listing them out, I'm just going to simply write this as 79 factorial. And that's like, this would represent all of the other numbers multiplied by themselves. Or by one less, I should say. Okay, so 79 factorial over 79 factorial, these are going to cancel out. This 79 factorial came straight from the denominator. So we can do 83 times 82 times 81 times 80, and we can solve, giving us 44,102,880. Now, just to check, I'm going to do 83 factorial divided by 79 factorial in my calculator. If I did this in my calculator, this gives me a math error. I have a pretty good calculator, but it's still not sufficient enough to calculate such a big number. So expanding like this, crossing out the 79 factorials is going to be the best bet. Okay, example 3. A band has 5 songs that they will be playing at the next school dance. In how many different orders can the band play all 5 songs? Okay, so as soon as we talk about orders, we know that order matters. So I'm going to do 5 underlines. 1, 2, 3, 4, 5. Okay, and we're going to fill in how many different songs can we choose for the first song. Well, we can choose 5 different ones for the first song. Then out of like that bucket, let's just say like there's a bucket of 5 songs. Say we chose this song. Okay, now if you think about it, how many songs can we choose for the second song? And we're assuming that they don't repeat. So let's choose this one. Okay, so there were 4 to choose from. And now there are 3 different songs to choose from. And now there are 2 different songs to choose from, right? 2. And now there's 1 different song to choose from. Okay, so 5 times 4 times 3 times 2 times 1 is actually the way we say 5 factorial. And so there are 120 different ways to order 5 songs. Okay, example 4, indirect method. So in how many ways could 10 questions on a test be arranged if the easiest question and the most difficult question, number 1, are side by side? So the assumption here is that you're not going to obviously repeat a question on the test. Okay, so all the questions are going to be unique. So I do this with the underlines as well. So the easiest and the most difficult question are side by side. So we're going to bundle these. Okay, so treat as 1. So if we're treating the easiest and the difficult as 1, instead of like 10 questions, we're really saying like 9 questions. 1, a little bit more. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and just know that one of these could be a grouping of 2 questions, the easiest and the most difficult. Okay, so one of these is 2 questions. So say the easiest and the difficult is here. I'm going to write this underneath. So how many ways can we order the easiest and difficult? Well, 2 factorial. I'm going to save that for a second. And then we have 9 slots to put in the questions, then 8, then 7, then 6, then 5, then 4, then 3, 2, 1, okay? And all of these are multiplied. So I would say that we had 9 factorial ways of arranging the questions. But then when we're talking about the arrangement and then order matters, what ends up happening is that this underline, or like it could have been any of these underlines, of the easiest and the difficult questions, since we clustered them together, would be 2 factorial. So we'd have to multiply this by 2 factorial, because for every single way that we order these, we could order them a second way, just like that's instead of easy and then difficult, difficult then easy, right? So we have easy, difficult, difficult, easy. So every situation is going to be multiplied by 2. So if I put this into my calculator, I get 725,760 different ways that we can order these numbers or these questions. So let's talk about the indirect method now. So if we want to find out the number of arrangements where the easiest and the most difficult questions are not side by side, we're going to use, let's use the indirect method. Okay, so what we're going to do is we're going to say what the total arrangements are, and then we're going to subtract the number of arrangements that are side by side. You know what, I'm going to use this notation. So the number of total arrangements, and we're going to subtract the ones that are side by side, and what we're going to do is we're going to get the number that are not side by side. So if we took, in general, 10 factorial, which is when you have 10 items, how many ways are there to list the items? 10 factorial. Okay, and if we subtract 9 factorial times 2 factorial, what do we get? Okay, so for 10 factorial, we get 3,628,000. And then we're going to subtract that 725, 760. And we get 2,903,040. And that's how many different ways that we can order the test, not side by side. So different ways to order the questions when easiest and difficult are not side by side. Okay, so we're going to talk about permutations. So a permutation of n distinct items is the arrangement of all the items in a definite order. Okay, so then this is when order matters. So permutation, order matters. It's not just a group of people or a group of items. It's when those groups have specific titles, like president, vice president, secretary, something like that. Okay. Or when you do when you're in a race, who comes first, who comes second, who comes third. Order obviously matters when we talk about metals. So when we order items, we use permutation notation. So it's going to be one of two things. We either use NPN, and those N's are actually subscript. So they're down here. Okay, or permutation n, n. So both of these are completely fine. I usually use the first one in class. So for a full factorial, NPN, say for example, we're doing like 50 items and we're ordering 50 items. 50 times 49 times 48 times 47, all the way to 3 times 2 times 1. This is actually going to be your full factorial. Okay, this is a formula since there are n ways of choosing the first item and then n minus 1 ways of choosing the second item, and so on and so on. Now, here's where it changes a little bit. Okay, so factorial is when we order every single item. Now, there are situations where we only order our number of items. Okay, and in this case, we're going to use, for example, 50, and then we're going to order, I don't know, 8 of the items, for example. Okay, so we can use 50p8 directly in our calculators. You will see the button NPR. Okay, the long formula for this is n factorial over n minus r factorial. So for example, this would be very similar to our question in 2b. This would be, for example, 50 factorial over 50 minus 8 factorial, which is 50 factorial over 42 factorial, just as an example. So example 5, suppose there are 6 people on a student council and all of them must say a speech at the end of the year assembly. Okay, in how many ways could this council give their speeches? Well, if all of them have to say their speech, then what we're going to do is we're either going to call it like 6 factorial, or there are 6 people and we're going to order 6 of them. And if you put these 2 different ways into your calculator, you are going to get 720. Okay, so there are 720 different ways to say the speeches. Now, if only 3 of the 6 individuals say a speech, let's call this B, in how many ways could the 3 individuals be chosen first, second, third? Okay, so in this case, we're talking about 6 people, order 3 of them. Okay, we can either put this straight into our calculator, or we can use the formula. So we're going to have 6 factorial over 6 minus 3 factorial, which is 6 factorial over 3 factorial. So I'm getting 120. And don't forget, if we have 6 people and we're ordering 3, all this is 6 people possible for the first speech, 5 people are possible for the second speech, and 4 people are possible for the third speech. That's all that means, is that we have 6 people to choose from, but we had to put 3 of them in order. Okay, so then there are 120 ways to say the speeches. Okay, example 6. In how many ways can a president, a vice president, and a secretary be chosen from 10 nominees? Okay, so we can do this one of 3 ways. So the quickest way is just saying, okay, there are 10 people and we want to order 3 of them. In other words, there are 3 spots, specifically president, vice president, and secretary. So if we choose one of the people for president, we have 10 people to choose from. If we choose one for the vice president, we now only have 9 people to choose from. And if we choose one for the secretary, there's 8 people left to choose from. Okay, so these are equivalent. We're going to get the same answer. The other way we can do this is the permutation formula where we have n factorial over n minus 3 factorial. And this is going to be n factorial over 7 factorial. Again, which would give us 10 times 9 times 8. So any of these approaches that you want to use, we're going to get the same answer. We're going to get 720 ways for a president, vice president, and secretary to be chosen.